Okay, we are now going to look at the nature of roots. Okay, so you should remember that we derived a quadratic formula which helps us to find the value of x. And finding the values of x is the same as finding the roots of an equation. So just remember those values of x are the roots. So what determines the type of a root is that value that is inside the square root, which we refer to as a delta. So the b squared minus 4ac will tell you what type of a root we have. Okay, so if this delta is equals to 0, then we know that we're going to have equal roots. If this delta is greater than 0, so just remember in mathematics when we say greater than 0, then we are talking about positive. Okay, greater than 0 means positive. So if our delta is positive or greater than 0, then we have real roots. If the delta is positive or greater than 0 and it's also a perfect square, then we are talking about real and rational roots. A perfect square would be, for an example, a 4, because we do have a square root of a 4, which is 2. It will be a 16. We do have a square root of a 16, which is a 4. But 3 is not a perfect square because we do not have a square root of 3. It will be 1 point something. Okay. So if a square root of something gives you a whole number, not a decimal number, then it makes it a perfect square, and we call such a rational number. But if your delta is less than 0, so in mathematics, again, less than 0 means negative. Okay, so if your delta is less than 0 or negative, then we know that we are dealing with non-real roots. So what kind of questions do you get from such? All right, so let's look at this question paper 1.5 then. It says, for any real values of p, prove the roots of that expression are non-real. Okay, let's write our expression down. The expression is xp squared then we have plus 3 equals to 2x p minus x. 2x into p minus x. Okay, so let's go back to the question again. They want to know, for any real values of p, prove that the expression are non-real. All right, we're going to get non-real roots out of that, basically. So obviously then we have to put this in a standard form, everything in a standard form. Okay, so let's multiply out. So if we multiply this out, it's going to give us x squared p squared. Then we have plus 3. On the right hand side, we're going to have 2x times p, which is 2px. And then 2x times minus x will then be minus 2x squared. Then we're going to transfer everything to the left hand side. Okay, so then we will have, I'm just going to put p squared to come first. We will have p squared x squared. And then this now will be plus 2x squared. And then transferring this one will be minus 2px. And then we have plus 3 equals to 0. There's a common factor x squared on the two first terms. So if we take it out, we're going to have this open bracket p squared plus 2, and the common factor is x squared. We have minus 2px plus 3 equals to 0. So now this is in a standard form. We have x squared x and a constant, and if you remember, any coefficient of x squared is a, any coefficient of x is b, and the constant is c. All right, so what is our delta? Our delta, we know it to be b squared minus 4ac. All right, so let's see, b squared minus 4ac will be equals to, remember that determines the nature of the roots. That's why we are using the delta. Okay, so our b is minus 2p, so we have minus 2p squared. We are substituting minus 4. Our a is p squared plus 2 plus 2, and our c is 3. So we have a 3 there, 4ac. So this will be equals to 4p squared, sorry, minus 2p squared will be minus 2 squared is a 4, and p squared is p squared. So we have 4p squared, then minus times, minus 4 times 3 is a 12, and then times this p squared, we're going to have minus 12p squared. And lastly, we have minus 4 times that 3 again, it's minus 12. And then that minus 12 times this 2, it's going to give us minus 24. We have like terms p squared. So ultimately, this will give us minus 4 minus 8. Minus 12 is minus 8. P squared minus 24. All right, so what makes a root non-real? Okay, if delta is less than 0 or negative. Remember the question, we are looking for when roots are non-real. We want the values of p that will make this non-real. So what will make this whole expression non-real? We know that for anything to be non-real, then we should get a negative square root. Okay, a square root of anything, minus 20, minus 1, minus 4. So long as you have square root of a negative number, then that is unreal. So what will make this expression a negative? It's all values of p, really. So we can test it out. What if p is 0? Then this will be minus 24. The answer will be minus 24, because anything multiplied by 0 is 0. Then we don't have a square root of minus 24. You can check it out on your calculator. A square root of any negative number will give you an error. So if you say square root of minus 24, it's going to give you an error. Then what if p is 1? Then it's going to be minus 8 times 1. It's going to be negative 8 minus 4. The answer will still be negative. It can be a bigger number than p. So let's say 1,000. It's still going to be minus by a negative 8. You know that any positive number multiplied by a negative is going to be a negative. So we'll have a negative minus a negative. The answer will be negative. How about negative numbers? Minus 1. So just remember now p squared. If we go minus 1, is going to be minus 1 squared. and then any negative number raised to an even number like a 2 there becomes a positive. So for the p squared, it doesn't matter whether it's a minus a million, a minus 8, a minus 25. Whatever value that is negative of p, there's going to come out positive in that squared. So now again, we're going to go back to a positive number multiplied by a negative number. Then it's going to be a negative minus a negative, it will be a negative. So all values of p will make that expression a negative. So p should then be an element of all real numbers, meaning from minus infinity to a positive infinity, or z really. All right, so we've answered that. The values of p, it's all real numbers. Okay, from minus infinity 0 and all numbers of positive 0 will make the expression minus 8p squared minus 24 a negative. And we do know that we cannot have a negative of a square of a square root of a negative number. So all values of p will then make the root non-real. Let's look at the next question. All right, change color. All right, so the next question now says, it's question 1.3 then. The roots of an equation f at x equals to 0 are, they've used the quadratic formula to find that expression. Determine the values of m for which the roots will be non-real. Non-real again. What is a condition of roots being non-real? Delta has to be negative. Okay, the roots are non-real if delta is negative. Okay, let me just rub this out again. Okay, that is a condition of roots being non-real. And then also what constitutes a nature of a root? It is the value that is in the square root, the delta part. All right, I'm just rubbing this out. All right, so let's go back. So on this expression, you will see that what's inside the square root is 16 minus 4m into minus m plus 5. That part is a delta. That's what will determine when the roots are non-real. All right, so that expression of a delta is 16 minus 4m into minus m plus 5 into minus m plus 5. So we've taken out the delta part. It's the expression inside the square root. All right, so the question says determine for which values of m will the roots be non-real. So the condition is that they will be non-real if the delta is less than 0. So we've taken out the delta there, and then we say less than 0. So, and then we go and find the values of m. So let's multiply out. It's going to be 16 minus 4m times minus m is going to be plus 4m squared, and minus 4m times plus 5 will be minus 20m. We have less than 0. Okay, in a standard form it's going to be 4m squared minus 20m plus 16 less than 0. And then we do have a common factor, which is a 4, so we're going to divide everywhere by 4. Then this will become m squared minus 5m plus 4 less than 0. And then we've done factors in the previous video, so you will see that the factors of 4, such that when you multiply them they give you a 4, and when you subtract them, when you add them, they give you a 5. That will be a 4 and the 1, not 2 and 2, because 2 and 2, when you multiply, yes, it will give you a 4, but when you add them up, it's going to give you 4, not 5. All right, let me just erase this out. So the factors of this, okay, by now we know that if it's a negative and a positive there, then both brackets are going to be negative. The factors of m squared can only be m times m, and that of 4 in this case will be 4 and 1, okay, 4 and 1. So then minus 4m plus minus m will give us minus 5m. Therefore, m is less than 0, or not less than 0, less than 5. M will be less than 4, less than 4 from this one, or M is less than 1. All right, but now 1 comes before 4. We have to have something like that there. So we cannot have these values both being less than 4 and a 1 all going to the left hand side. So it doesn't make mathematical sense. So that means it's the values between 1 and 4. So then we need to change the m less than 1 and make it greater than 1. All the values that are greater than 1 but then less than 4. So that means then m is between 4 and a 1. So that will be your answer. You can even test it out. The values that between 1 and 4 is 2 and 3. So if you take 2 out, substitute 2 into this value, if it gives you a negative, you can do it in your calculator. If it gives you a negative, then we know that yes, we have proved that it's non-real. All right, so let's see. 2 times minus 4 is going to be minus 8, and then minus 2 plus 5 is 3. So 8 times 3 is then 8 times 3 is then minus 24. Then that means we're going to have 16 minus 24. That's a negative. And then you can also substitute a 3. You will definitely get a minus, and all other values are going to make it non-real. So that means it's for when m is equals to 2 and 3, which is values between 1 and 4. All right, so it's either you say m is less than 4, or m is greater than 1, or you say m is between 1 and 4. And then the last example for this one. Alrighty. So the last example is on question 1.3. Again, if f at x equals to 0 has the roots of that expression, for which values of k will the roots be equal? Okay, so again, remember we are interested in the delta. The delta in this case is that expression inside the square root, which is 3 minus 12k squared. 3 minus 12k squared. 3 minus, okay, I'm not sure why this is happening. Well, I'll just write underneath here 3 minus 12k squared, 12k squared. Okay, that's the delta. They're talking about the roots, then we are interested in the delta. 3 minus 12k squared. And then they want to know for which values of k will the roots be equal. Let's go check what is the condition of the roots being equal. That's when delta is equals to 0. So our delta is 3 minus 12k squared, so we have to equate it to 0 because that's what make roots equal. All right. Sorry, real. So then we get to solve for k. I'm going to then transfer the 3 to the right hand side. That means we will be left with minus 12k squared equals to minus 3. And then next we're going to divide both sides by minus 12 because we are looking for k. Then we will have minus 12 cancelling with minus 12, we are left with k squared equals to minus 3 divided by minus 3 is 1, and then minus 12 divided by minus 3 is 4. Okay, almost done. Then we're going to take square root on both sides to offset that square. All right, square root of k squared will then be k equals to square root of 1 is 1. Remember, we have plus or minus, and then the square root of 4 is 2. Okay, so your k would have to be plus or minus 1 over 2 for that thing to have equal roots. All right, and then you can also test it out with a negative. You will see that with a negative, it's still going to be a positive, so it will definitely not be non-real. And then a positive number, it will also give us a positive square root. So the answer is k equals to plus or minus a half. All right, so it's 4 conditions when the roots are equal. Real, it's greater than 0, or less than, that's non-real. Okay, so that is it for the nature of roots.